In this video, we're learning how to use SOHCAHTOA to find the missing sides and angles in right triangles. And if you guys haven't already done so, I encourage you to watch our other video, which is an introduction to SOHCAHTOA, just so you guys know the basics of how to use it. So looking at example 1, we have this right triangle where we're given an angle of 30 degrees, and we're given one side measuring 6 inches, and we're trying to solve for one of the other sides. So what we want to do is figure out how these sides relate to 30 degrees. Are they the opposite side, adjacent side, or hypotenuse? So that's what we always want to do first. So if we look at the side labeled X, we'll notice that it is across from the 30-degree angle. So it's the leg that's across from the 30-degree angle, so that means this is our opposite side. And if we look at the side labeled 6 inches, it's our other leg, and it's touching the 30-degree angle, or it makes up the 30-degree angle along with the hypotenuse. So this is our adjacent side. So now what we want to do is look at our 3 trig ratios up top and see which one uses opposite and adjacent sides. And if you take a look, you'll probably notice that it's tangent. So now what we want to do is set up a tangent equation based on this triangle. So first I'm just going to write that tangent is equal to opposite over adjacent. Now I'm going to plug in what we know. So we're going to find the tangent of 30 degrees, and we're going to say that's equal to our opposite side, which is x, over our adjacent side, which is 6. And now we need to solve this for x. So to get x by itself, we're going to multiply both sides of our equation by 6. On the left, we get 6 times the tangent of 30 degrees. And on the right, the 6's cancel out and go to 1, so we're left with x. So we get that x is equal to 6 times the tangent of 30 degrees. And now some teachers will allow you to leave it like that, but some teachers appreciate if you find a decimal approximation. So let me show you guys how to do that. So x is equal to 6 times some number tangent of 30 degrees. So let's find the tangent of 30 degrees by just putting that into our calculator. And if you do that, you should get that it's approximately 0.577. And now we're just going to multiply those together in our calculator, and we're going to get that x is approximately 3.462. So we get that x is equal to 6 times the tangent of 30 degrees, or approximately 3.462. And one quick thing to note, if you guys carry this decimal through in your calculator without rounding it, your final answer of your decimal approximation may be a little bit different than mine. It may be a couple digits off in the thousands place. That's fine. It's just because I rounded that decimal throughout. So now let's go over one more example where we're solving for a missing side. So in this next example, we are again given an angle, and we are given one side, and we have to solve for one of the other sides. So let's figure out how these sides relate to this angle. So this side that is labeled 8 feet is one of the legs, but it is not across from our 42-degree angle. So this is our adjacent side. And then the side labeled X is across from the 90-degree angle. So this is our hypotenuse. So now we have to figure out which trig ratio uses adjacent and hypotenuse. And if we take a look, we're going to see that it is the cosine. So we want to set up an equation for the cosine of 42 degrees. So we know cosine is equal to adjacent over hypotenuse. So the cosine of 42 degrees is equal to our adjacent side, which is 8 feet, over our hypotenuse, which is x. And this time, what we're solving for, x, is in our denominator. So what we want to do first is multiply both sides of our equation by x to get it out of the denominator. On the left, we're going to get x times the cosine of 42 degrees. On the right, the x's cancel and go to 1, so we're just left with 8. And now finally, to get the x by itself, we're just going to divide both sides of our equation by cosine of 42 degrees to get that x is equal to 8 over the cosine of 42 degrees. And again, some teachers may allow you to leave your answer like this, but let's find a decimal approximation as well. So we know x is equal to 8 over the cosine of 42 degrees. So in your calculator, you're just going to go ahead and find the cosine of 42 degrees, which is about 0.743. And now what you want to do is just divide 8 by that number. And if you do that, you should get that x is approximately 10.767. So we get that x is approximately 10.767, or x is equal to 8 over the cosine of 42 degrees. Now let's go through a couple examples where we're solving for a missing angle. So in this example, we are solving for this missing angle and it's labeled theta, and theta is just a variable that we commonly use when we're dealing with angles. So we want to figure out how these sides relate to the angle that we're solving for. So this side labeled 7 centimeters is across from theta. So this is our opposite side. And then this side labeled 10 centimeters is our other leg. So this is our adjacent side. So now we want to look at which trig ratio uses opposite and adjacent, and we are going to get tangent. So we're going to do a similar thing that we've been doing, except for this time our angle is our unknown. So we're going to say that the tangent of theta is equal to our opposite side, which is 7, over our adjacent side, which is 10. And now we have to remember how to solve for an angle that is in one of our trig functions. So to get rid of this tangent, because we want to get the theta by itself, we have to do the inverse operation, which is tangent inverse. So what we're going to do is take the tangent inverse of both sides of our equation. And on the left side, taking the tangent inverse of tangent just cancels out, and we're left with a theta. And on the right side, we just get tangent inverse of 7/10. And now what we want to do is put this into our calculator. So first I would just put 7/10 into our calculator, and we'll get 0.7. And now in our calculator, we want to put in the tangent inverse of 0.7. And if you do that, you should get roughly 34.99, and that is in degrees because we're solving for an angle. So we get that theta is roughly 34.99 degrees. Let's go through one more example. So for this last example, I encourage you guys to pause the video and try it on your own, and then you can watch me work through it to make sure that you've solved it correctly. So again, in this example, we're solving for an angle, and we are given 2 of the sides. So this side labeled 5 centimeters is across from theta, so this is our opposite side. And the side labeled 13 centimeters is across from the 90-degree angle, so this is our hypotenuse. So now we need to figure out which trig ratio uses opposite and hypotenuse, and that is going to be sine. So we need to set up an equation for sine of theta. So sine of theta is equal to the opposite side, which we know is 5 centimeters, over the hypotenuse, which we know is 13. And now to solve for theta, we need to take the sine inverse of both sides of our equation. So we're going to take the sine inverse of sine theta, and we're going to take the sine inverse of 5 over 13. And the sine inverse of sine is just theta, so the sine and sine inverse cancel each other out. And on the right side, we are just left with the sine inverse of 5 over 13. And now let's just plug this straight into our calculator. Last time 7/10 was a nice decimal. 5/13 is going to get a little bit ugly. So instead of rounding throughout, let's just put into our calculator the sine inverse of 5 over 13. And if you do that, you should get approximately 22.62 degrees as your theta. So hopefully this video helped you guys understand how to use SOHCAHTOA to find the missing sides and angles in a right triangle. If you want some more practice with problems like this, check out the link in our description for a free practice worksheet.